Hi everyone. Now I'm going to present our group testing project on YouTube DLP, an open source command line tool for downloading videos from YouTube and other platforms. We chose the project because it's actively maintained, written in Python and widely used. Our goal was to test its functionality, stability, and user experience. For testing strategies, we applied a hybrid testing strategy: white box testing to check internal logic and source code, black box testing to simulate user behavior, and gray box testing for integrate between models. For example, we use Python's unit test to test internal files like test YouTube signature.py, which ensures the video signature is parsed correctly. We also tested installation on Windows to make sure users can set it up easily. For gray box testing, we focus on how different components interact, like test http.py, which checks HTTP response handling. And then for the test design, we designed 10 functional and 10 non-functional test cases. Functional tests included downloading videos with different URLs and formats. Non-functional tests focus on performance and accessibility. For example, whether it works with only keyboard input or screen readers. One specific task we created was test empty cookie load. It checks that the cookie is empty before use, which prevents potential secure issues. Some tests were automated, others were manual, especially those related to usability and installation. Through the test, we should learn that this project helps us understand how to test real-world open source tools. We learn how to apply different testing techniques and focus on high-risk areas. Most importantly, we saw how tests adds value by improving software quality and user trust. And then is environment and test tools.
Hello everyone, I will talk about the testing environment and tools we used in our project, and also a quick overview of the existing tests. First is the environment. We used a laptop with Intel 7 processor, 60 grams of RAM, and 512 GB SSD. That's basically the normal thing we use as a developer. And our main system was Windows 11, but we also tested some features using other systems. In that way, we can check the cross-platform compatibility. And we created this kind of Python 3.8 virtual environment for testing using this Venom module. All command lines were done using PowerShell. And for internet-related tests, we used a local HTTP server. And this helped us simulate downloading and other internet behavior without depending on the actual external connection. Now for the tools, we mainly used Python's unit test framework. And this is great for white box testing. We also done some black box testing using this kind of, we run the actual YouTube DLP.exe program to do the black box testing. And we also used idle to do some quick tests on some smaller modules. Now I will briefly mention some of the existing tests that are already included in this project. This comes with a pretty large set of tests. They are all allocated in the test folder. And for example, we have this kind of test YouTube MISCPY. This checks if videos are correctly handled. We have tests HTTP proxy PY. And this is more about if the proxy server are working properly, and we have test download PY to ensure videos are downloaded correctly. In total, there were over 30 different sets of files. They cover basically everything from cookie handling to subtitle freezing, networking, and even plugin loading. So generally, we use a realistic setup with proper tools and environments. We tested across platforms and we reviewed and ran many existing tests to make sure we were not missing anything important. Now let's come to the writing tests.
Okay. In writing tests, we write a simple unit test to check if extract ID method can correctly extract YouTube video ID. So you can copy it and paste it in Python, and the result is pass. And we conduct a total of 21 tests on the software to ensure its functional correctness, performance, robustness, and real-world usability. These tests were grouped into 3 categories: functional, non-functional, and other validation tests. Can you turn to next page?
Yeah.
Okay. So the first is functional tests. These are white box unit tests based on the original test files from GitHub repository. We run each test file individually using idle and judge the result based on whether the script completed with an OK message or failed due to exceptions. And the models tested include URL and playlist extraction, age restriction handling, subtitles parsing, verbose output security, and utility functions like file name synthesization and data range parsing. File overwriting and config loading. The results are 7 of the past passed. Core features like URL extraction, config handling, and file overwrite worked as expected, and 3 tests failed. Problems appeared in playlist extraction logic, subtitle format, handling, and utility function edge cases. In non-functional tests, we also run black box tests using the pre-compiled YouTube PLP extraction release to evaluate how the software behaves under practical conditions. The test features include installation, startup time, CPU, memory, and disk usage, resource cleanup, proxy support, error handling robustness, and cross-platform compatibility. The results are all non-functional tests are parsed. For example, the software stayed under acceptable CPU and memory usage, even during long downloads. And the last is other test. We also verified if the latest version could download videos from YouTube as expected, and it passed. So functionally, most core features are stable, so a few edge case tests failed and may require fix. Non-functionally, the toy is lightweight, efficient, and robust in real usage. Overall, the software performs reliably and is ready for daily use. So next, my friend will talk about the bug and risk report.
Yeah, about the bug report, we found the 3 main issues during the testings. The first bug is about the playlist extraction in the functional test 2. And the problem is about it failed to handle empty tails in the flat models. It affects users to charming channels with no upload. The second bug is about the cross-platform path in the functional test 5. It is about the inconsistent field name synchronization across the Windows and Linux. So it make the mirror, but could frustrate users with specific characters in paths. And the third bug is about the subtitle parsing in the functional test 8. It is failed to parse the certain format, and it limits the accessibility for users relying on subtitle. So about the risk report, the core functionality is stable and production ready, but the edge case need fixed before full relight. And the non-functional test all passed, but scannability under high load remain untested. So we suggest for the software, we suggest is fixed playlist and subtitle handling, and ensure the constant path handling across the OS. Add the auto retry for unstable connections. And our suggestions for the testing is about simulate the real-world scenarios and conduct the load testing more than 100 concurrent users and improve the accessibility testings like the screen readers, keyboard navigation. In conclusion, the YouTube DLP is a mature and effective tool. By making targeted improvement to address the discovery issues, it has the potential to become a more reliable and feature-rich video download solution. And our project shows the importance of the software testing in software development and maintenance. That's all. Thank you.